So, we have to talk about file systems. And I have to explain to you, the book only shows you how to write a file and how to read a file. But it tells you how they work. And I think it's important for you to understand how the actual file system works, how it's physically put together. So, we're going to take a conventional hard drive, the one that spins. Then we can talk about solid states. Well, for now, have you ever opened a hard drive? We got this disk, looks, and then you have this arm and like a needle here. And you got some circuitry here, and you got the plugs over here, right? So, it looks like a vinyl display. Basically it is. So, we have this, just like a vinyl player. It has tracks. And it has, if you look at a vinyl player, it has a needle, right? That's touching the disc. Well, this one has, it's not really a needle. It's kind of like a magnet here, a square magnet. And it's the size, one of those tracks. So it's like a bucket, let's say. It doesn't read 1 byte at a time or 1 bit at a time. It's just like this bucket. And it goes over a position and grabs all the bits are in that position and brings it over. Those we call them sectors. So if you ever heard, oh, I have a bad drive that has bad sectors, it's because it can read them all. The hard drive has this memory too. It's like a RAM. But we don't call it RAM. We're gonna call it DMA. But it works like a RAM. It's a buffer, basically. This is a buffer. And this DMA, we call it direct memory access. Just think of it as a RAM. Is where we read and write stuff from the operating system. There's something called transactions too. Like if you think of a bank transaction, you know, you get a bill from the cable company, and it says, whatever you owe, $50. You write a check, if you still write checks, send it out. The company receives your check, and it says, oh, we're gonna apply $50 towards your account. But it's in limbo. It's like in here. It's not here yet. And then your cable company deposits a check in their bank account. And the bank account says, oh, you have this much in your account, $50 more, but it's not all available. So their bank calls your bank. And they say, hey, I got a check for $50 from this guy. Does he have the funds? And the bank says, yeah, he does. Then, okay, give me the $50, puts it in my account, or the company account, and then the money is applied, then it's credited completely to your cable account, and it's withdrawn from your bank. So that's called a commit. The bank transaction is committed, so it's saved here. If your bank calls, their bank calls your bank and you don't have the money, nope, he writes fictions, they said, because money doesn't exist. Well, really, money doesn't exist literally, but so we go back and your bank says, oh man, you tried to write a rubber check, bounced, no. We're gonna charge you whatever, 25 bucks, non-sufficient funds. Your cable company is gonna charge you another 10 bucks or 35 bucks, whatever they charge you. And then they're gonna say you owe the original amount plus the penalties, right? That's called a rollback. So when you have a transaction, there's a series of steps, and if you commit to the transaction, then it's saved. If the transaction, something happens, it is rolled back in the reverse order these steps were put in. So that's what this memory works. It's gonna write only when it's ready to commit. Sometimes, if the buffer is full, then it writes the chunk at once. It's just for speed issues of purposes. If you look at the disk horizontally, it's actually might be more than one plate. We call those disks, and they're all in the spindle. And this arm, there's the arm that you see on the top. It goes here. Actually, there's another one touching this one here, and this one here, and this one here, and this one here. So there's a bunch of heads, one touching each of the surfaces of the disk. So when you get a conventional hard drive, you have to look at the speed. You know, those cheap computers that you don't believe they're that cheap is because they have an AMD processor and they have a 5400 RPM hard drive that nobody wants. So the RPM, revolutions per minute, is just how fast that thing spins around. But that's not the only factor that is determined in a hard drive. See, all the arms, they all move together. They don't cross. So in essence, in here I have 4 disks, I have 8 surfaces, 8 heads, but I'm only using one at a time, because the other ones are just going along for the ride, because this thing moves all together, and this is spinning at the same direction. They're not out of sync. So there's a distance, and the distance, let's say, if I'm in the middle of the plate, my arm is in the middle of the plate, the time it'll take to get to either end of the plate, so to read basically the whole half of the disk, it's called latency. So basically, what's the delay of moving that arm around? And then, how many bits can this put out or come in at once to the DMA of the CPU, of the motherboard? So how many bits I can send at once, and that's called a transfer rate. So these two are really reduced almost to almost zero if you have an SSD drive, because there's no moving parts. That's the advantage of a solid state drive, is because nothing's moving. So, let's say, well, I don't think anybody is cop here, but if you watch a movie, you know, they gotta go to the evidence room. And there's a case and they're just given boxes. Right here is a box for this case. The boxes are all the same size. Right? So that's what this thing grabs, that box. And then puts that box in here, that fits. And then you're looking for a particular folder or file or whatever, then you search that box in here, not in here, because it'll take too long. So when you program, you don't get to write this directly or read directly. You read from the buffer. So each plate, or we call it this 0, you know, it's like an array. I know you love arrays. So, at the top of this 0 here is the sector 0, and that's where I'm going to ask, when the computer starts up, that's where it's going to look for instructions what to do. So the first thing the computer does at boot up is reads the motherboard, and we saw that at the beginning of the semester, and it sees what's connected to the motherboard, pulls everything, and every component replies, and then now it has an idea, or it knows what's going on, and then loads the operating system. But in order to load the operating system, goes to the hard drive, and then it goes to this sector and say, hey, where do I load the operating system? And then it'll say, well, actually the operating system is in here or in another disk, or if you have dual boots or whatever. I thought I turned that off. Oops, sorry. Hey, Halloween already passed. We have ghosts. Right, little ghost. Little ghost, you're the scariest of the most. Why do you like the white stripes? Anyways. So, that's how physically the hard drive moves. Now, can I erase this?
Yeah.
All right, so when you go to the library, or used to go and look at the shoebox with a bunch of index cards, and then you start looking alphabetically, like that array we were talking about. You're looking for a specific book title, and then you found the book title, and then, oh, it's in shelf, whatever, H of aisle 15, so you walk there and then grab the book, right, where it said it was, and then you check it out, whatever. So the computer works similarly. So if we don't care, I mean, the index cards don't have really a name, right? The book has the name, title, but the index card is just index cards. So if you were to look at the shoebox, you'll see index card, maybe they're from 0 to 1 to whatever, 10,000. If you just count the order they are, but really the cards itself, index cards, don't have a name. Right? So we'll assign it. We'll assign one. We'll just assign a sequential number. So we're gonna call that file ID, and that a sequential number of the. It's like the index card. And then instead of calling it book name, I'm gonna call it file name. It has a field, the file name, whatever you call it. Me at Christmas.jpg or whatever. And there's another one called just a bit, a boolean. It's a folder or not. I'll show you why. Then you have a parent. Then you might have there's a bunch of other columns. I'm just gonna call it attributes. Right? So if we use a sequential file ID instead of file 1, and that I'm gonna call it users. And I forgot something here. Before the attributes, I'm gonna have an address. And then I'll have the attributes. So the user is actually a folder. So I'm gonna put a 1. And there's no parent. There's no address. And I don't care about the attributes. And then under the users, there's another folder. That's your user ID. So I'm gonna call that student just for the example. And it is a folder. And the parent is actually 1. It's that one. No address and whatever. Under the student, under that folder, I have another one called documents. It's also a folder. The parent will be 2 now. No address. And you may have another one called pictures, right? It's also under the student. And then you add another file. And this one is going to be called my resume.docx. So it's a Word document with your resume. And that goes in your documents, right? So it's not a folder. And it's in 3. And now is the physical address in the hard drive where it's located. But this is the beginning address of the file. And we're going to see why. Like in an array, you just get the beginning address, right? And then you add another picture. Another file. And this is me.jpg. And then it's not a folder, it's under my pictures. And it's an address, I don't know, maybe 1500. So There are other attributes like size, state, modify, and all those things that I don't get into too much detail. But I want you to see, if you have two drives in your computer, if you have a large folder and you want to copy it to the other, it takes a few moments, right? You can see the green bar going because it's copying. So, but if I copy me.jpg from pictures, if I cut it and paste it into documents, even if this one is like 10 gigs, it goes really quick because it doesn't move them in the hard drive. All it does is change one field, change it to the parent. That's all it does. So it changes the file structure. Physically, the file is still in the same spot. If I were to copy and paste it from a folder to another, then I'll have two copies. Then yes, it'll take actually take longer because since remember the ARM, it's only reading one at the same time. It has to read one sector, put it in the buffer, and then go back to another side of the hard drive and write it, and then go back and doing this dance. So this architecture, if you will, we call it a FAT. Stands for File Allocation Table. So I can say I'm a little file allocated table. And then it's followed by how many bits I use for my file ID. So if you have a SD card from your camera and put it in your computer, it says what type it is. Have you ever formatted one of those? I'll tell you, right? And it says, right now probably it says FAT32. FAT16, FAT8, whatever. So basically I got 32 bits to allocate files and folders. Now that worked great. So FAT16 was Windows 95, then 98 came with, I think it was 98 that started FAT32 to get more files. But then, have you ever scanned your computer for viruses? Mm-hmm. How many files do they show up on folders? Like a gazillion, right? So this doesn't work too well with large files. I'm sorry, large drives. It works with your SD card, your flash card for your camera or your phone, whatever. But it really doesn't work that well in a computer. Another thing when they thought about this was, what if I want to share my drive? I want to share a folder. If you share a folder from the guest computer, it shows like another drive. You can map a drive and actually it's just a share folder. Yeah. So then it got complicated. So I need more space and I need to be able to track something called locks. What's a lock? So I have physically this sector in a hard drive and I'm writing to it, or I'm going to be writing to it. I can't allow anybody to read or write to it, any other computer. They have to wait. If they want to read it, they can read it after I'm done writing. That's called a protected data. So what's happening is it's kind of hard to manage all that in a FAT32. I mean, it's not impossible, but it's very limited. So they came up with a different type of file structure that works kind of the same way. And they call it NTFS. And this is Network File System. And this network file system locally has a table similarly to this, but it's not called FAT. It's called MFT, and that stands for Master File Table. So this master file table hopefully is located at the beginning of the disk, and that way when the drive is looking for something, you can find it always in the same spot. There has some flaws in this, and one of the flaws is if you have the hard drive, you have this hard drive here physically. The computer starts, and when you install the operating system, your master file table is here. And then you start writing stuff right after. So you put other files in here. But when the master file table is located, it's just enough for the operating system. And then you install Office, and then you install Photoshop, and then you install all this other stuff. That table doesn't fit anymore. Alright, so let's put MFT part 2 here. And then at the end, if it's not here, I'm going to put a link there. And then you make another one. Those are not files, these are those shoe boxes. It's like going to the library and there's a shoe box and there's more books than index cards that can fit in that box. And then at the last one says, for more index cards, go look at aisle 15, shelf G or something. And then you go there and it's not there and it says, for more index cards, go. You're gonna be running around all over the library, right? Good cardio, but the disk doesn't think that way. So when you defrag your hard drive, what you're doing is defragging the files, the green ones. You don't defrag the master file table. And that makes your computer really slow. So, because Windows don't come with an access, maybe Windows 10 does, I don't know. I don't think it does. But I use this program. I think it's this keeper with 1K. Something like that. Or maybe DISC keeper. I'm not sure. So what this program does is a DOS program that runs with a little code in the boot up in the sector 0, and then runs this DOS program that defrags the master file table and then moves the files out, making room. And that will make your computer really fast. So far so good? So, you wrote your resume, and your resume fits here. And then you added that me.jpg, and it's here. And then you want to add that picture to your resume. I don't know why, I got some resumes with people's picture. I'm like, that could be a good thing or a bad thing. You're like, hell no, or you're like, I mean, so what happens if you're trying to add to it? Well, you can't write because there's already something after. So this is the resume continuation, and all it does is a jump. What do you mean a jump? So in the array of an array of characters, how do we know the string ends? Because it has a null terminator, right? Same thing with the files. When do we know a file ends? Because it has a null terminator. But instead of having just the null, it's actually a null address, a null pointer. So the file ends when it reaches that null pointer. But if the file is appended later, that null pointer is changed to the address of the second segment, or the third segment, or whatever. So that's how you get your file fragmented. When you defrag, that means put all the whole file, put it together. Instead of having first chapter in this box and the second chapter in the other box, or whatever, if you're thinking of a library. So when we have to run it manually, the defrag for the hard drive. You don't have to for the RAM. The RAM, there's a scheduled program that runs every couple minutes and defrags the RAM. And that's called the garbage collector. Did I tell you about that? We'll talk about it in detail next semester. So now this master file table is bigger now, allows you to have like 2 terabytes. And then if it's more than that, you have to format it differently, and so on. So questions. So this is, in a nutshell, how the file system works. So when you write a program, you get a pointer to the RAM, to the buffer of the hard drive. You read and write from that buffer. Some people, when they format their hard drive, you can do a quick format and a long format. If you do a quick format, all it does is erases this master file table. Everything else is still there. So if you format regular conventional format, it doesn't put everything in zeros. There's still voltage there. It's kind of like just passing a broom real quick. You get to pass it a few times if you want it really clean. So what happens when there's a pedophile going to this child pornography websites, and then the police catches them? So they come and format the hard drive. Not a regular format, but a long format. So they seize the computer. I can get that computer and I can still reconstruct what was in the hard drive. Because it's not like you sit and scrub the hard drive with a toothbrush or something. I mean, the only way to really erase everything is if you burn it. Or maybe if you put, I don't know, maybe if you take the disk and put it in your motorcycle's brakes with a very high magnet. I don't know if that'll erase it. But, so some people accidentally erase their photos or whatever, or they get a virus, or the drive gets corrupted. I can still get the stuff. People care about their pictures, most of it. And sometimes they're not as perfect because if the picture is fragmented, I get the top in one file and then whatever continuation. Then they had to use Photoshop to put it together, but it's better picture that is divided in two rather than lost the whole picture, right? So that's how the hard drives work, and that's how this file system works. And we're gonna create programs, next class, with using those pointers. And remember, a pointer is just an address to hold an address. It's just that the address it's holding is not holding an address in the RAM, but an address in the RAM of the hard drive. That's all it is. It works the same way. The computer doesn't know the difference. All right, no questions? All right, go have lunch. Early. Brunch.